Okay, momentum. Momentum is mass times velocity. If the question says what is momentum or define momentum, you would say mass times velocity. The unit of mass is kilograms, the unit of velocity is meters per second, so therefore the unit of momentum is those two put together, which is kilograms meters per second. The symbol for momentum is P, symbol for mass is M, symbol for velocity is V, and again it can be put into a triangle like that, so you can come up with different values of M, P and V. Just a couple of things to notice. Notice that if you increase the mass of an object, you would increase the momentum it has. And if you increase the velocity of an object, you will increase the momentum that it has. This is very important. You're going to have to remember this word for word, make a revision card on this. The law of conservation momentum is this, that in a closed system, the total momentum before an event is equal to the total momentum after an event. What do we mean by closed system? A closed system is when you have a collision, you look at everything that took part in a collision, the cars before, and you look at the cars afterwards, and you make sure you counted all the pieces in there. So if a wheel flies off, you must make sure you count that wheel. Nothing's allowed to come into the system or out of the system or out of the environment. Basically, you count everything that took part in that event. Remember that word for word in terms of the law of conservation momentum. Perhaps the best way to illustrate this is by using an example here. Let's imagine we've got two trolleys. One trolley A with a mass of 50 kilograms travelling at 6 meters per second colliding into a trolley B with a mass of 200 kilograms travelling at 1 meter per second, that should say, 1 meter per second. The question is, what will happen when those two collide? At what speed will the joint combined trolley move at? And using the law of conservation momentum, you can work it out. We know that the momentum before must equal the momentum after. So let's look at the momentum before. The total momentum before was the momentum of A plus the momentum of B. And the momentum of A is mass of A times the velocity of A. The momentum of B is the mass of B times the velocity of B. And if we stick those values in there, you find that the momentum of A is 50 times 6, which is 300. The momentum of B is 200 times 1 meter per second, which is 200. So the total momentum is 500 kilogram meters per second. So that is the momentum before. And using the law of conservation momentum, it is also the momentum afterwards. So the total momentum before is 500 kilogram meters per second, and the total momentum after must also be 500 kilogram meters per second. And that will equal mass times velocity. The mass is the mass of A and B combined, and the velocity of A and B. So we know that 500 will equal the mass of A and B. Well, A was 50 kilograms, B was 200 kilograms. You add those two together, you get 250. So you've got 500 equals 250 times the velocity of A and B are joined together, so they'll travel at the same speed. Now, if you rearrange the formula there, you get 500 divided by 250 will give you the velocity of A and B combined, and you can see that the A and B combined, will travel at 2 meters per second. So you're able to use the conservation momentum and the formula for momentum to predict as how these things will behave. This is likely to be a grade B, a grade A or A star question. This is quite a tough question. But if you got that far, that is a tremendous achievement. And if I were you, I'd practice a few more examples to really master this topic.